All right, so let's do some truth tables. So we're going to show that P and Q is logically equivalent as Q and P. So when I set these up, usually, most people with these can pretty quickly get true, 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 false, false, true, false, false. Or I like to think of it a pattern, true, true, false, false, and then this one goes true, false, true, false. Either way, you make sure you get every situation. So let's look at P and Q. You can either write the word or you can do the symbol. Um, and, I usually just do the symbol because it fits better in these little spots. So P and Q, if I had a true statement and a true statement, then I get a true statement. If I have true and a false, I get false, because remember, and is very strict. If I have false and true, I get false. False and false is definitely false. So now, you got to ignore that's there. Maybe even cover it up if it helps your brain. Okay. And here, sometimes you have to read them backwards. So when you do Q and P, you're actually saying, what if I have a true statement and a true statement? It goes this way to this way. True and true is still true. If I have a false first and a true second, it's still false because and is very strict. If I have a true then a false, it's false. And if I have a false then a false, it's false with and. So it shows that the order doesn't matter with an and statement. See, this one is logically equivalent to that one because every single value is the same, true, false. If any one of these were different, you would say they're not logically equivalent. All right. Okay. So now we're going to try to show that this thing, not outside of P and not Q, is logically equivalent to not P or Q. All right. So you have to build them, and usually you have to build them separately. So I don't know. Let's try to build this. Okay. If you want to do a not P and Q, I first want to build a P and not Q. Now before I build that, I kind of start at the most inside. I need the basic building blocks, and right now I just have P and Q. You can go ahead and fill those in. True, true, false, false. True, false, true, false. Right? And I'm going to build this. So I'm going to go not Q. Well, if regular Q is true, false, true, false, not Q is the opposite every time. So true becomes false, false becomes true. There we go. Now that I have this, I can build this part. So I'm going to build the P and not Q before I do the final cherry on top and then not the whole thing. So these truth tables are pretty easy because you're just building it one piece at a time. Now this is sometimes hard for people, so I cover up what you don't want. Okay, sometimes you have to do that with a pencil, sometimes you do it with your finger, sometimes you just do it with your brain. But if I want P and not Q, I want to go true and false. What's true and false? It's false because and is strict. True and true. It's true. False and false is definitely false. False and true is still false. So my final statement is, okay, I built this. Now I can finally chuck on that tilde and say not P and not Q. Not the quantity of P and not Q. So now I just not this one before it. I don't have to ever do a big move. I'm just doing the negation of this. So negation of false is true. Negation of true is false. Negation of false is true. Negation of false is true. So that's the end result. I'm going to compare this guy to my results when I do this one. If I want to build this, if I want to OR them together, I already have a column for Q, but I don't have a column for not P. So I'm going to build a not P. And when I build a not P, I just look at... Okay, so now I build not P, and I have to block out all the things here and just look at P. So if P is true, true, false, false, right here, and this one's going to be false, false, true, true. And my final step will be to take not P or Q. So here's where you got to kind of block out a bunch of stuff, right? We're going to block that out. And all right, so I'm going to go, if I want to build not P or Q, I block out everything on my picture other than not P and Q. I'm going to do or. So not P or Q is false or true. It's true because or is very lenient, right? False or false is false. True or true, very true. And true or false is true because it's lenient. So I'm going to compare this to the other one I circled. Now look at them. Those two are logically equivalent to each other. All right, so now let's crank out some more. It should move a little quicker now, now that we got this going. All right, so now we're going to prove De Morgan's law. Okay, so remember, De Morgan's law is on the other side of this page, and it says that if you do a not version of P and Q, it equals not P or not Q. So those say they're logically equivalent. I want to prove it, so we kind of just build it, right? Okay, so let's do the De Morgan's Law 1. There's two of them. We're just doing the first one. So I probably want a not P and a not Q for later. Okay, so if P is, remember you're blocking out this. If P is true, true, false, false, then not P is false, false, true, true. And then if Q is true, false, and this one's false, true, true. All right, so now I'm going to try to build the not P and Q. Okay, so first I might want regular P and Q. Right, P and, oh shoot, I made an A. Gosh darn it. P and Q. So here's where you got to kind of block out some of it. Okay, so if I want P and Q, I got true and true is true. True and false is false, because and is very strict. False and true is false. False and false is false. But in De Morgan's Law, I want a not version of that. So not P and Q would just be the logical opposite of this. So true becomes false, and falses become true. I'm going to compare that answer to the other side. Remember, De Morgan's Law is this, not P and Q equals, and it kind of distributes to all of them, not P or not Q. Okay. Now we already have the building blocks for that way over here. So we're going to cover these up and look at, we're going to cover both of these up, right? So kind of got just focus on there. You know, if it takes post-it notes, it takes post-it notes. Okay, you probably don't need this much help, but so now I'm going to OR these together. So false or false is false. False or true is true because OR is lenient. True or false is true, and true or true is true. So I'm going to compare this to my other answer. And wouldn't you know it, they're the same, which is why it's called De Morgan's Law and not De Morgan's wrong thing. All right, so I want to show that this is a contradiction. Remember, contradiction should be something that's always false. So if you say P and not P or Q, you just build it, right? True, true, false, false. True, false, true, false. And then I'm going to try to build this. So how about I build a regular P or Q first? Always start inside out. And then at the end, I'm going to add that not to it. So let's do a regular P or Q. You can use the word or, I don't really care. True or true is true. True or false is true because it's lenient. False or true is true, and that's false. And now I'm going to not that thing. Not P or Q. Oh, I wrote it this time. So a not version would be just to take, here I'll cover that up, just take your previous one and change every symbol, because the negation of true is false, and the negation of false is true. And now we want to take this answer, see this is a compound one, and we are going to AND it with P. So we're going to take that guy and we're going to combine them with P. So I got to kind of block out the middle, right? So I'm going to P AND with this thing. So I'm going to go, oops, let me move that over. Okay. So true and false. Hold on, let me write this down. P and not P or Q. Okay. So true and false is false because it's strict. True and false is false because it's strict. False and false is false. False and true is false because it's strict. This right here is a contradiction. It is a statement that is always false. Okay, so now for the grand finale, what the heck do you do if you have 3 letters involved? You have to think of every combination of 3 letters. True, 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 false, true, false, true. But I have a good pattern for you. You kind of just do it in patterns and you won't mess up. You won't miss any. Because I guarantee if you try to do this in your head, you'd probably miss one. You could have, I go 4 trues, 4 falses. Then I go 2 trues, 2 falses, 2 trues, 2 falses. And then alternate, true, false, true, false. And you'll see every single one of these is different. But you have every case, true, 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 false, true, false, true, true, false, 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 true, true, false, true, false, false, true, and false, false, false. Those are the only choices. So here we're going to build these, and we're going to show things are not logically equivalent. So if I'm going to build this, I first need to build a P and Q. Okay, P and Q. So ignore this line exists, right? And we're going to go true and true is true. True and true is true. True and false, it's strict. So you just got to remember which ones are strict and which ones aren't. Pretty easy, right? And now I'm going to OR this. We're going to OR it with regular R. So we're basically using this. Technically our order should matter, even though with ORs it doesn't. But I'm going to go true or true is true. True or false is true because OR is lenient. False or true is true. False or false, here we go, we finally got a false. False or true, lenient. False or false, false. False or true, lenient. False or false, false. Okay, so we built this one. We're going to compare this guy to the other one. So let's build the other one. So we're going to try to build this, P and Q or R. So first I want to build a Q or R. And then we will AND it with a P. So Q or R, you kind of got to put your blinders on here and get your ORs going. True or true is true. True or false is true. Lenient, here's your first false because those two are both false. Then true, 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 false. Now we're going to AND this with P. So P and Q or R. And the hardest part is just kind of blocking out what you don't need, right? So we have Q or R there. We have P with it. So we're going to kind of put P with it. Block that out. So you're going all the way across here. So true and true is true. True and true is true. True and true is true. Here we go. And it's strict. So true and false is false. The rest of them are going to be false because they all start with false. Okay. And it's strict. All right, now I'm comparing this one to the other one. Let's see. Starts off, you're like, hey, these are the same. True, 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 false. Uh-oh. Here's an indication, and here, that they are not logically equivalent. All right, pretty good stuff. Hope that helped. Good times, man, good times.